Welcome back to TechSpectrumPro. We've journeyed far into the world of wireless area networks, and today we dive even deeper. Let's take a quick trip down memory lane. We started our one adventure by establishing a solid foundation with wireless fundamentals and standards. From there, we moved on to SSID configuration and RF fundamentals, honing our skills and understanding of the technical aspects of wireless networks. We then shifted our focus to security, exploring wireless encryption and best practices to ensure our networks are secure. We put theory into practice by configuring and verifying wireless LANs, followed by a hands-on approach to wireless site survey and troubleshooting. Most recently, we navigated the complex world of wireless controllers and management access, a crucial component of any robust network. And now, prepare to venture into the realm of advanced WLAN settings and QoS profiles. Advanced WLAN settings offer a level of customization and control that can dramatically enhance your wireless network's performance. These settings are not just about tweaking your network for a better Wi-Fi signal. They're about creating a network that works specifically for you, your needs, and your environment. This customization is crucial in today's digital world, where wireless networks are under constant demand from multiple devices, applications, and users. Advanced WLAN settings encompass a broad range of configurations. One of the key settings is the channel width, which can be adjusted to improve network speed and capacity. By increasing the channel width, you can allow more data to pass through your network at once, potentially improving its overall speed. Another important setting is the transmission power. This controls the strength of the signal your router sends out. By adjusting this setting, you can extend your network's range or limit it to a specific area. This is particularly useful in densely populated areas where you may want to avoid interference from other networks. Then there's the frequency band. Most modern routers allow you to choose between 2.4 GHz and 5 GHz frequency bands. While the 2.4 GHz band offers better range, the 5 GHz band provides faster data speeds. This choice will depend on your specific needs and the devices you're using on your network. Next, we have the security mode. This setting determines the type of encryption your network uses to protect your data. The stronger the encryption, the safer your network will be from potential intruders. However, stronger encryption might also slow down your network, so you'll need to strike a balance between security and performance. Finally, there's the SSID broadcast. This setting controls whether your network's name is publicly visible or not. Disabling the SSID broadcast can add an extra layer of security by making your network less visible to potential hackers. With these settings, you can fine-tune your WLAN to meet your specific needs and optimize its performance. Remember, there's no one-size-fits-all solution when it comes to wireless networks. It's about finding the right balance for your unique situation. So, let's dive a little deeper into these settings and see how you can get the most out of your wireless network. Now, it's time to delve into the specifics of these advanced WLAN settings. Peeling back the layers, let's first take a look at the Transmission Power Control, TPC. This setting allows for the adjustment of the WLAN's radio frequency power level. It's a balancing act, really. Too high, and you risk interference with other networks. Too low, and your coverage area shrinks. Next up is Dynamic Frequency Selection, DFS. This setting is all about making the most of the available frequencies. In a crowded wireless environment, DFS can automatically switch your WLAN to a less crowded frequency, reducing interference and enhancing performance. Then we have the beacon interval. This is essentially the heartbeat of your WLAN. It's the frequency at which your access point announces its presence to devices. A shorter interval can mean faster device connections, but at the cost of increased network traffic. Now, let's move to the RTS-CTS threshold. This setting controls the size of data packets on your network. Smaller packets can result in fewer errors, but can also lead to more network overhead. The fragmentation threshold is another setting to consider. It determines the maximum size for a packet before it's broken into smaller pieces. Lowering this threshold can reduce errors at the cost of network efficiency. Finally, we have the DTIM interval. This is a countdown timer that tells devices when to wake up and check for multicast or broadcast data. A shorter DTIM interval can help with battery life on connected devices, but it can also increase network traffic. It's a delicate dance, isn't it? Each setting has its own unique implications, and managing them effectively is what separates the good from the great in network engineering. Understanding these settings is crucial for optimizing your WLAN and ensuring it meets your needs. So take the time to experiment, observe, and adjust. After all, the devil is in the details, and in the world of WLANs, these details can make all the difference. Let's transition to another vital aspect of WLAN configuration, QoS Profiles. Now you might be wondering, what exactly are QoS Profiles? Well, QoS stands for Quality of Service. In the realm of networking, it's a set of techniques aimed at managing network resources. These profiles essentially dictate how to prioritize different types of data traffic on your network. Imagine your network as a highway and the data packets as cars. Now, there are different types of cars, each with their unique purpose. Some are ambulances, some are trucks, and some are casual commuters. QoS profiles act like the traffic police, deciding which car gets to go first based on priority. Why is this important? Let's stick with our highway analogy. Without traffic management, an ambulance might get stuck in traffic while a casual commuter breezes through. That's hardly fair, isn't it? Similarly, without QoS, a crucial video conference might lag because someone else is downloading a large file. QoS profiles help us avoid this by prioritizing certain types of traffic over others. For instance, you might want to prioritize voice and video traffic over general web browsing. This ensures that your important video calls don't suffer just because someone else is watching cat videos on YouTube. But it's not just about preventing lag. QoS also helps to manage network congestion and can improve the overall performance of your network. It ensures that the most crucial data gets through, even when your network is under heavy load. And don't worry if this all seems complicated. Most modern networking equipment comes with predefined QoS profiles that you can use as a starting point. You can then customize these profiles to suit the specific needs of your network. Remember, every network is unique. The best QoS settings for your network will depend on your specific needs and the types of traffic that are most common on your network. QoS profiles provide a means to prioritize traffic and ensure a smooth, high-quality network experience. Now that we know what QoS profiles are and why they're important, let's dive deeper into how to configure and verify them. Let's delve into the specifics of QoS profiles. Quality of service, or QoS, is a critical aspect of managing network traffic. It allows us to prioritize certain types of data over others, ensuring that the most important information gets through even during times of high network usage. So, how do we configure QoS profiles? Well, it's not as complicated as it might sound. The first step is to access your network device's settings. This could be a router, switch, or wireless access point. Once there, look for the QoS settings. You might find these under Advanced Settings, or they could be in a dedicated QoS section. Within the QoS settings, you'll typically find options to prioritize different types of data. For instance, Voice over IP, or VoIP, often needs to be prioritized to ensure clear, uninterrupted calls. Similarly, video streaming might be prioritized to prevent buffering. You can usually set these priorities yourself based on what's most important for your network. For instance, if you're running a business that relies on VoIP calls, you'd want to prioritize that data. On the other hand, if you're running a video streaming service, you'd want to prioritize video data. Now, verifying your QoS profiles is just as important as setting them up. You'll want to test your network under various conditions to make sure your priorities are working as intended. There are several tools available for this, many of which can simulate high network usage and show you how your QoS settings are affecting traffic. Remember, QoS isn't a set-it-and-forget-it solution. It needs to be monitored and adjusted as your network needs change. But with careful configuration and regular testing, QoS can be a powerful tool in maintaining a smooth, efficient network. To sum up, QoS profiles are a key component in managing network traffic. They allow us to prioritize certain types of data, ensuring smooth network operation even during high usage periods. By properly configuring these profiles and regularly testing their effectiveness, we can ensure our network is running at peak performance. By properly configuring your QoS profiles, you can ensure your network runs smoothly and efficiently. We've covered a lot of ground today, diving deep into advanced WLAN settings and QoS profiles. We kicked off by exploring the intricacies of advanced WLAN settings, looking at how they can be used to enhance the performance and security of wireless networks. We then delved into the realm of QoS profiles, learning how to configure and verify them for optimal network performance. These two aspects of wireless networking are integral to ensuring a smooth, secure, and efficient network operation. They allow us to manage and prioritize network resources, ensuring that critical data is delivered promptly and reliably. Our exploration has reinforced the importance of both advanced WLAN settings and QoS profiles in managing and optimizing wireless networks. But remember, this is just one part of the vast landscape of network engineering. Thank you for joining us on this journey into advanced WLAN settings and QoS profiles. Stay tuned for our next episode where we'll explore guest wireless networks and BYOD policies. Until then, keep exploring and expanding your tech knowledge with TechSpectrumPro.